Hello everyone and welcome back to the Leetcode grind. Today we're continuing our mock online assessment series with 71 simplified path. It says here, given an absolute path for a Unix style file system, which begins with a slash, transform this path into its simplified canonical path. Very confusing. Let's read on. In Unix-style file system context, a single period signifies the current directory. A double period denotes moving up one directory, and multiple slashes, such as this, and it says multiple, so it can be 2, 3, 4, are interpreted as a single slash. In this problem, treat sequences of periods not covered by the previous rules like 3 dots. So 1 dot is current, 2 dot is above, 3 dot is neither of those. So that should be considered as valid names for files or directories. Now, the simplified canonical path should adhere to the following rules. It must start with a single slash. So whatever we end up returning, it must start with it. Directories within the path should be separated by only one slash. Also, it should not end with a slash unless it's the root directory. So this should not end with this guy. However, if we have something like this, which, you pop up, you are at the home, you do return the front slash. And it should exclude any single or double periods used to denote current or parent directories. Yeah, okay. So what can we use that can help us? First of all, it looks like a valid path has single slashes. So first, just off the bat, we want to make sure that if there are multiple slashes like this guy, we want to have just one. So the simplest thing we can do is use the module and then update our string. So we're taking this path, we're gonna sub with an expression or a pattern. That pattern will be more than one slash. So we're gonna use the regex, we're gonna use this library to substitute anytime we find multiple slashes, so that's pluses for more than one slash, we're gonna replace it with a single slash. And we're doing that to our input, which is path. This is our input string, such as this guy. We're updating, let's see, do we have the three parameters. We have the pattern we're using, what we're replacing it with, and then the actual input. Okay, but the other thing is we want to process each part separately. So let's say that the parts will be that dot split. And now we know we have a single slash between every part. So home is a part, foo is a part, 2 dots is a part, along with 3 dots. That's a separate part. So we're gonna split it by a single slash. Okay, so at this point, we have our parts, which are, in this case, you know what? Let's actually visualize this. Let's see, this is example 5. And I'm gonna print parts and return just empty string. Okay, so that's going to be this guy. So if you look here, the parts will be all of these, separated by a single slash, given this. Okay, so given that, we're going to also have a stack. And a stack is helpful because, for instance, if we hit 2 of these, then we want to pop back up to the parent directory. And a stack, we can pop the ends off very easily. So for part in parts, then we say, okay, if it's a single dot, that means it's a current directory. So we don't really need to do anything. So if part is empty, is a single dot, that means we're in the current directory, so we can just continue on, move on to the next part. Okay, otherwise, If the part happens to be two dots, then this is what we're using the stack for. Then, and we do have to check that there is anything to pop off. If there is a stack, then stack dot pop. So we move up the directory and then make sure that there is something to pop off, then pop it off. Now, otherwise, it means it's not a single dot, it's not two dots, it's three dots or some other string value. It can be anything, but otherwise it is valid and we instead append to our stack. Okay, at the end, we will get different ranges of values, which may or may not start with the starting slash. So the way we can fix that is explicitly set res to begin with that, but then strip whatever we have. So first of all, stack, we're going to join back, where since we're splitting it with this, we can join it back. From that join string, we're going to purposely strip the first starting slash, if there happens to be one, because we're going to explicitly set it. And then we also want to strip the ending slash if there happens to be one. L strip, left strip, and right strip, these are useful for stripping characters that are not guaranteed to be there. So this will not throw an error. It'll only process if there is anything to strip, and otherwise it will not do anything. And at the end, then we can return explicitly starting with a slash plus whatever we have here. And then we can give that a run. And I know I click really quickly, so this is the code. And then let's give that a submit. And there we have it. Wow, that's pretty fast. Okay, so back to the problem. Just to review, what we did here was we first replaced all the multiple slashes, so more than one slash with a single slash. Then we separated each component, each part, into an array of different parts split by the single slash, which we join back with a single slash at the end. Then using a stack so that we can pop off the ends easily. For every part in the parts, if it's a single dot, it's a current directory, so we ignore, we move on to the next part. Now, if it's two dots, we want to pop back up to the parent only if there is a stack. So as long as there is a stack, then we pop off that guy. Otherwise, it's valid, so we append that part, and then we join it back with a slash, and at the end, if there happens to be a starting slash, then we remove it. And we do that because we want to explicitly add it to the beginning in case we get, like depending on the input, we can get a result at this point starting with a slash, or we may get something without a starting slash. Then no matter what, we want to return the slash. So we're saying, hey, the first slash will handle it, so don't add it, please. So remove it if it's there, and the ending slash, we don't want it anyway, so remove it, please. And then return it with that. And that's pretty much it. Thanks so much. This was once again the online assessment series for 71 Simplified Path. Thanks so much. Happy coding, and see you next time.